Welcome to the Deep Dive. Today, we're diving deep into the work of Ivan Pavlov.
Pavlov and his dogs.
Yeah, but we're going way beyond the simple bell and salivation thing everyone knows.
I think people will be surprised by just how deep his research went.
Absolutely. We'll explore how it still impacts psychology and even everyday habits.
It's pretty amazing how relevant his work still is today.
I've got some fascinating material to work with. Excerpts from Pavlov's own books like Conditioned Reflexes
And the work of the digestive glands, a classic.
and a biographical sketch, 25 years of objective study, to add some context.
Looking forward to getting into it.
Me too.
Yeah.
So to set the scene, Pavlov started with a very unglamorous subject, digestion.
Right. Who knew drool would be so revolutionary, huh?
Well, he was a dedicated physiologist.
Totally. And what's fascinating is that through that work, he actually stumbled upon a phenomenon that changed how we understand behavior. He was studying digestion in dogs,
Yeah.
meticulously measuring their gastric and pancreatic secretions.
Okay, hold on. For those of us who haven't cracked open a physiology textbook lately, how did he even measure those secretions? I mean, we're talking about the inside of a dog's stomach here.
That's where Pavlov's ingenuity comes in. He used surgically created fistulas.
Fistulas.
Yeah, small openings that allowed him to collect the gastric and pancreatic juices directly. Pure, no contamination.
Wow, that's pretty groundbreaking for the time.
Oh, absolutely. It was.
So he's got these dogs, he's got these fistulas, he's measuring all these juices. What happens next?
Well, that's when the aha moment hits. Pavlov noticed the dogs were salivating before the food even showed up.
Really?
Yeah, like they were anticipating the meal based on, cues in the environment.
So it wasn't the food itself making them drool.
Exactly. It was as if they'd learned to associate other things with the food. Things that, on the surface, had nothing to do with eating.
Like what kind of things?
Oh, like the footsteps of the lab assistant bringing the food.
Yeah.
Or the sound of the food bowl. Even just a specific time of day.
Fascinating. So these random things became predictors of food, and that led to what he called conditioned reflexes.
Exactly.
Okay, so we've got the basics set up. But how did he actually prove that this association, this conditioning was really happening?
Pavlov was a meticulous experimenter. He designed a series of really elegant experiments to test his ideas. He'd pair a neutral stimulus, like the sound of a metronome,
Okay.
with the presentation of food.
Got it.
Over time, the dogs would start to salivate in response to the metronome alone, even without any food present.
Just the sound.
Just the sound. He even used this technique called sham feeding.
Sham feeding. What's that?
So the dogs would see and smell the food, but it never actually reached their stomach.
Clever. So that proves the salivation was a learned response to the cue, not the act of eating itself.
Exactly. He isolated the variable and boom, classical conditioning.
So through these super carefully controlled experiments, he was able to map out the mechanics of this whole learning process.
He did.
This might seem pretty straightforward now, but this was a huge deal back then, right?
Oh, it was revolutionary. Back then, introspection and subjective interpretation were still very big in the study of the mind.
Yeah, psychology was still a pretty young field.
Exactly. And Pavlov brought real objectivity and scientific rigor to it. He moved away from those subjective interpretations of animal behavior,
Right.
and focused on observable, measurable, physiological responses like salivation.
Hard data.
Exactly. This really laid the foundation for a more scientific study of the nervous system, especially the brain.
Okay, so we've got the basics of classical conditioning down. But Pavlov didn't just stop at bells and metronomes, did he?
Oh, not at all. He was incredibly thorough. He explored all sorts of stimuli, lights, tactile sensations, even rotating objects.
Wow, so it wasn't just about sound.
Nope. And he discovered that dogs could differentiate between very similar stimuli, like they would only respond to the one that consistently predicted food.
So if you used two slightly different tones, but only one always came before food.
They'd learn to tell them apart and only salivate to the food tone. It's remarkable.
That is pretty amazing. So they were really fine-tuning their responses.
Yeah. And he also found that if the conditioned stimulus, say that metronome sound, was presented over and over without any food,
Okay.
the salivation response would gradually fade away. He called that extinction.
So the learned response wasn't permanent.
Right. Think of it like a doorbell. If it keeps ringing but no one's ever there, eventually you stop reacting to it.
Makes sense. So what about generalization? What did he learn about that?
Yes. So generalization is when stimuli similar to the conditioned stimulus could also trigger a response, but weaker.
So like a slightly different tone might still cause some salivation, but not as much as the original one.
Exactly. It's like a ripple effect, spreading out from the original learned association.
Fascinating. So there's this whole spectrum of responses based on how similar the stimulus is to the original one.
You got it. And, his work revealed even more complexities. He found that if you pushed the dogs too far, made them distinguish between really subtle stimuli,
Hmm.
they could actually develop what he called experimental neuroses.
Neuroses.
In dogs, yeah. They would get agitated, anxious, even show physical symptoms.
Wow. That's kind of disturbing.
It was. But it showed just how delicate the balance of excitation and inhibition is in the brain. Even the learning process itself could have negative consequences if pushed too far.
So he was really uncovering a deep connection between learning behavior and the actual physiology of the nervous system.
He was a pioneer. And it's amazing how much we can still learn from his work today.
Absolutely. But let's zoom out a bit. How do these findings about, dogs drooling translate to us humans?
That's the beauty of it. Pavlov's work wasn't just about dogs. He uncovered fundamental principles of learning that apply across species, and that's where it gets really interesting. Pavlov's research with dogs really had a huge impact on how we understand human behavior.
Yeah, it's pretty mind-blowing. Those experiments with drool and metronomes hold clues to phobias and addictions, even how we form habits.
It's incredible. It shows how powerful basic learning mechanisms are and how they influence us in so many ways. Let's start with phobias.
Okay. So how does a dog drooling at the sound of a metronome relate to, say, someone being terrified of spiders?
Well, imagine a phobia, an intense, irrational fear.
Right.
It could be of anything, really. But let's say spiders.
Yep.
Maybe a bad experience, way back in childhood, links the sight of a spider with feeling terrified.
So the spider becomes like the metronome, and the fear, that's like the salivation.
Exactly. The spider, which was a neutral thing before, now triggers a fear response. Just the thought of a spider can cause anxiety.
So you're saying our fears can be learned, not necessarily something we're born with.
That's a key takeaway from Pavlov. Many of our fears come from experience, through conditioning. And just like Pavlov's dogs could unlearn the metronome-food connection,
Right.
therapies for phobias often use gradual exposure to the feared object.
In a safe way, of course.
Of course, but the idea is to break that link between the spider and fear, like hitting an unlearn button.
By showing the person that the spider won't actually hurt them.
Right. Over and over, without any bad consequences. The fear response weakens.
Makes sense. So how about addictions? Where does classical conditioning fit into that?
Addictions are complicated, but classical conditioning is a big part of it. Over time, the act of smoking, let's say,
Okay.
becomes linked with certain places, people, maybe even feelings.
So those things become triggers, like just seeing a cigarette pack could make someone crave a smoke.
Exactly. Those cues, they were neutral at one point, but now they're like Pavlov's metronome triggering cravings. It makes quitting so much harder.
So it's not just the substance itself, it's the learned associations that are so powerful.
That's the key. And understanding that has led to therapies that focus on breaking those associations, helping people avoid those trigger situations.
To kind of reset the learning.
Yeah. And then there's emotional conditioning.
Oh yeah, you mentioned that earlier. What's an example of that?
Think about how a certain song or maybe a smell can evoke strong emotions.
Yeah, I get that.
It's probably because those things are linked to memories from your past.
Like a song that was playing during a really happy time, hearing it again brings back all those good feelings.
Right. Or maybe a certain smell reminds you of your grandmother's house.
Yeah, things like that. So our emotions can become conditioned to certain triggers,
Yeah.
and we don't even realize it's happening.
Exactly. It shows how much our emotional responses are shaped by past associations, often without us knowing.
This is all starting to feel a bit like the Matrix. Like there's all this programming going on in our brains that we're not even aware of.
It's a good analogy. And understanding these mechanisms can be so helpful.
Yeah, like with habits.
Hmm.
How many times do you find yourself doing something without even thinking about it?
All the time, right? It's autopilot.
Totally. Like brushing my teeth before bed. It's just automatic at this point.
Exactly. In the beginning, you had to consciously remember. But over time, getting ready for bed became linked with brushing. Bedtime routine equals teeth brushing. It's a habit.
So if we understand these conditioning principles, we can actually break bad habits and build new, good ones.
That's the idea. If you know what cues trigger those unwanted behaviors,
You can start to change them.
right. break the old associations and make new ones that help you reach your goals.
So it's like rewiring your brain's circuitry.
Exactly. Becoming more aware of those unconscious associations and then consciously using those conditioning principles to create change.
This is pretty empowering. It's like we're not just prisoners of our past.
You're not. We can actually reshape those patterns. And that's one of the big things Pavlov did. He gave us a framework for understanding how learning shapes behavior and how to use that knowledge to have more control over our own lives.
That's huge. So it's not just about dogs drooling anymore.
Not at all. It's about understanding the power of learning and how it shapes who we are.
Okay, this is all so insightful. It really shows how much of what we do, the good and the bad, comes from these unconscious associations that Pavlov discovered.
And it's remarkable, he started with digestion in dogs and ended up having a huge impact on psychology, therapy, even neuroscience.
Speaking of which, what about the man himself?
Yeah.
What was he like? How did people react to his research back then?
Well, from that biographical sketch, it seems he was a fascinating guy, really dedicated, meticulous, but also, demanding, passionate about his work for sure.
I can imagine. And his findings, they must have been controversial at the time.
Oh, they were. People were skeptical. It challenged how they thought about the mind.
But his methods, his results, they were undeniable.
They were, and eventually he was recognized as one of the most influential scientists of the 20th century. He even won the Nobel Prize in 1904.
Wow, a Nobel Prize. That's incredible.
It is, and even though we have to consider the ethics of his animal experiments, which we'll talk about in a bit,
Right.
there's no denying the impact he had on science.
Absolutely. His work helped establish this idea that the brain isn't static. It can learn and adapt. It laid the groundwork for all the research on neuroplasticity, the brain rewiring itself.
Exactly. He wasn't just looking at behavior, he was shedding light on the physical changes in the brain that make learning possible.
So he was connecting the dots between behavior and what was happening at a neurological level.
He was, and his influence goes way beyond those initial findings. He shaped how people studied the brain in so many fields.
Speaking of broader implications, let's talk about the ethics of his work. We can't ignore the fact that he used animals in his research, which by today's standards raises a lot of questions.
You're right. We have to acknowledge those ethical complexities. It's a crucial part of his legacy.
So let's get into that. What are some of the concerns about his methods, and how does it all relate to his scientific practices today? So let's get into those ethical considerations. What were some of the concerns about using animals in Pavlov's experiments?
Well, the biggest one is probably pain and suffering. His experiments involve surgery, and manipulating the dogs' bodies to study those processes.
Yeah.
He stressed that it was important to minimize harm, but honestly,
Uh-huh.
those methods would be considered unethical by today's standards.
Definitely. Our understanding of animal welfare and the whole ethics of research has come a long way.
Oh, absolutely. Today, there's a big emphasis on the 3 R's in animal research: replacement, reduction, and refinement.
The 3 R's. Can you break those down for us?
Sure, replacement means trying to find alternatives to using animals.
Okay.
Like, can you use computer models instead? Or cell cultures?
So it's about exploring those options first before going to animal subjects.
Exactly. Then there's reduction. That means using the smallest number of animals possible to get good results.
Makes sense, both ethically and scientifically. You don't want to use more animals than you absolutely have to.
Right. And finally, refinement. That's about minimizing any pain or distress the animals experience.
So if you have to use animals, you make sure they're treated humanely.
Exactly. These principles, they show that we recognize animals deserve moral consideration.
Yeah, and that we have to minimize their suffering.
Absolutely. So, thinking about Pavlov's work,
Yeah.
it's important to remember the historical
This
context.
was different back then.
They were. The whole discussion about ethics in animal research wasn't as developed.
So while his methods might seem problematic now, back then they were pretty much accepted.
That's right. But his work and other research using animals, it really pushed those ethical discussions forward.
It made people think about the balance between scientific progress and animal welfare.
Exactly. It's a complicated legacy. On one hand, groundbreaking discoveries that changed how we understand learning. On the other, those ethical concerns that we can't ignore.
It's a reminder that science always needs a strong ethical compass, one that considers the well-being of all creatures.
Well said.
And, even though Pavlov's work has been so influential, it's important to remember it's not the whole story.
Right. Classical conditioning is just one piece of a very complex puzzle.
There's so more to human learning and behavior than just those basic associations.
Our genes, our environment, our own choices, they all play a role.
So while Pavlov gave us this great framework, it's not like humans are just robots programmed by our experiences.
Exactly. We have the power to make our own choices and shape our own lives.
Well, this has been an amazing deep dive. So much to think about. Any final thoughts you want to leave our listeners with?
How about this? Pavlov's work shows that even simple observations like dogs drooling can lead to huge discoveries.
Yeah,
It's about curiosity, careful observation, and doing rigorous experiments. But we also need to be thoughtful about the ethics of science, you know?
absolutely.
Mm,
Making sure our pursuit of knowledge is driven by compassion and respect for all life.
I couldn't have said it better myself.
And to everyone listening, thanks for joining us on this journey into the world of Pavlov. We hope you've gained a new appreciation for how we learn, the power of those unconscious associations, and the responsibilities we have as we explore the world through science. Keep those minds curious and keep diving deep.